All right, so audio is a bit high, I guess. 1 2 1 2. So here is our second stream for preparation for the SnowPro Core Certification, book by Marla Ferle, and we're gonna just jump straight. All right, we're gonna jump in and continue with views. Again, we have 2 hours. We have strictly 2 hours now, so good luck. Views. Snowflake supports creating standard SQL views. A view is basically a named definition of a query that allows I will just grab this. That allows the result of the query to be used as if it were a table. The results of a view are created by executing the query at the time that the query is referenced in another query. Views serve many purposes, such as protecting data by exposing only a subset of the data in the underlying table, or simplifying complex queries by hiding part of the query logic behind a view that is used in another query. Particularly, any SQL query can be used to create a view. The query is specified in the create view statement. For example, to create a view that selects all customers from the United States, these are identified in the C country column containing the value US, the following statement can be executed. I'm gonna just do one thing because this is bad. This is very much a convoluted way, I would say, to say this. How would you say this otherwise? So The results of a view are created by executing the query at the time that the view is referenced in another query. I think you could say this in a much more understandable way. The results of a view are created by the results of a view. The results of a view are created by executing the query at the time the results of a view are created by executing the query at the time that the view is referenced in another query. This is so weird. But anyway, from what I understand is like basically a view. The point is that it's storage cost. So we store a query. Views serve many purposes, such as protecting data by exposing only a subset of the data in the underlying tables, or simplifying complex queries by hiding part of the query logic behind a view that is then used in another query. Results of a view are created by executing the query at the time so maybe that's what it means. Maybe it means I don't know, I guess. Anyway. So again, we're gonna reuse our transient table this time, but we're gonna do create view customer view US. selects all customers from the United States. But we don't even have a data, no? We don't have data yet. But it's okay, it's created. If the schema is not specified, Snowflake assumes that the table is in the same schema as the view. Caution, in many databases, when you create a view and don't specify the schema, the database will use the current schema. This behavior differs from Snowflake. So be sure you understand this concept thoroughly. Used in Snowflake, if the schema is not specified, Snowflake assumes that the table is in the same schema as the view. So not the current schema. I don't understand again. I don't understand because like, what do you mean this behavior differs from Snowflake? So be sure you understand this concept. Like, what do you mean it differs? Like if I have now the sales data schema, right? And I just created the view. Obviously it was created in the current schema. The database will use the current schema. In many databases, when you create a view and don't specify the schema, the database will use the current schema, right? So now, okay, let's open the database explorer, and we're gonna go to sales and sales data. and views, and here's my view. So I didn't specify the schema, and it was using the current schema. So I don't understand. I don't understand the caution part. Okay, so I guess this is going to be the time we're gonna actually ask AI. But we agree that we're not gonna ask for AI because AI is basically a shortcut to just a given answer, and it's gonna convince you no matter what, right? Like it's gonna give you a conclusion which is like, okay, I guess it makes sense because it makes sense, but you will not have this the connection in your brain. Like these realizations have to be made like from your simple human logic. Here you have to like get things to understand. Like if you have set answers, then how do you expect to learn? I created a view and didn't specify the schema, and it was created, and anyway, the takeaway is that if the table is in the table, if the takeaway is that if the table is in a different schema on which you want to use, okay, I'm gonna say on which you want to use the view, then of course specify the location of the table with the dot notation. That's it. The takeaway is that if the table is in a different schema on which you want to use the view on, then specify the path of the table by using the dot notation. So select from customer, so and we always, in production, we always use the dot notation because we don't want to get fucked. So views in Snowflake are read-only, which means that you cannot execute DML commands such as update. Data types. Snowflake supports most basic SQL data types that can be used in columns, variables, expressions, or parameters. The main data type groups in Snowflake are numeric data types, string and binary data types, logical data types, date and time data types, semi-structured data types, geospatial data types. When data types are compatible, a value expressed in one data type can be converted to another data type. For example, integer data type can be converted to float, or string data can be converted into date if the date format in the provided string is recognized by Snowflake. Data type conversion is done implicitly by Snowflake whenever possible. Users can explicitly cast a value from one data type to another data type using any of the following functions as operators. The cast function, for example, cast amount as integer. The operator, the corresponding SQL function if available, for example, to date. So what I need from Happiness now, what is missing, is a Kindle holder. Actually, Kindle holder like this. Like it would stand like this, that would be awesome. Or like this, I don't know. And what else? In a streamcast, that I could just press the button when I wanna say like, you can get this later, okay, it's okay. Semi-structured data types, geospatial. When data types are compatible, a value expressed in one data type can be, when compatible, the value can be converted from one data type to another data type. Integer to float, string to date, and so on. Data type conversion is done implicitly by Snowflake whenever possible. Users can also explicitly cast the value from one data type to another data type using the following functions and operators. I don't know what it means. Snowflake supports fixed point and floating point data types. The most commonly used fixed point data type is number. It can store up to 38 digits with an optional precision, the number of digits, and scale the number of digits to the right of the decimal point, for example, number 18.2. Okay, this is very nice, because I was always wondering what the fuck those two numbers mean next to the bracket, like in the brackets. Synonyms for number and decimal are numeric. To define integer data types, number 38.0 can be used, which indicates 0 digits to the right of the decimal point. Synonyms for integer data types include int, integer, big int, small int, and others, where you don't specify the precision and scale. Floating point numbers can be defined as float, float 4, float 8, double, real, and others. All of these are represented as 64-bit floating point double precision numbers in Snowflake. I will grab the cat if he's here. Come on, learn about numeric data types, please. Snowflake supports. I need to rewrite it in my own words. Snowflake supports fixed point and floating point numeric data types. So fixed point The most commonly used fixed point data type is number. Okay. Synonyms for integer data types can int, integer, and others where you don't specify the precision and scale. I will ask somebody. I'm gonna ask somebody. Who is good with math? Oh, yes, Roxanne. What does it even mean that you can store up to 38 digits? Like, what do you mean 38 digits? Up to? Total number. What is the total number? What does this mean? I really have no idea what I'm doing, really honestly. Anyway, moving on. Floating point, I'm just gonna write it down because this is just extremely slow. Floating point numbers can be defined all of these are represented as 64-bit floating point double precision numbers. Snowflake supports data type varchar that stores Unicode UTF-8 characters with character strings. The varchar keyword accepts an optional parameter which represents the maximum number of characters that will be stored, for example, varchar 255. If you don't specify the parameter, the maximum allowed length, which is a lot of big number, will be used. A varchar is also limited to maximum number of bytes, which is 16 megabytes. Remember the 16 megabyte limit. This is not only the maximum allowed length of a character string, but also the size of a Snowflake micropartition, which limits the size of all objects and values that can be stored as a single unit in Snowflake. Snowflake supports the binary type for binary strings. The maximum length of a binary string is 8 megabytes, regardless of the encoding. The size limit is set at 8 megabytes, so the variable fits within 16 megabytes when converted to a hexadecimal string. Maybe we can do a break. 45 minutes. Let's do 5 minutes of just looking at the wall. But I need to disable the autoplay, but where do I do it? Anyway, we are back. We are not bullshitting. We are continuing immediately. We can have one more 5-minute break at the time when I have to log in. Where was I? Which is 16 megabytes. Snowflake supports Boolean as logical data type with true, false, or null values. The null value represents an unknown value, just like in other data types. Boolean values can be converted from text string and numeric values to logical values according to the following mappings. String that represents true values, true to, String that represents false values, the numbers, okay, this is very easy. And this is really all part of Snowflake architecture, I guess it does. But whatever. Why? Okay. Yo. Snowflake supports data types for storing dates, time. Yes, exactly. That's what I'm talking about. Because this is which we use all the fucking time. Snowflake supports data types for storing dates, times, and timestamps. The date data type is used for storing dates with no time parts. It recognizes dates in the most common formats such as YYY month, day, day, month, year, and more. Snowflake supports the following data types for storing timestamps. Timestamps underscore LTZ. Internally, the value is stored as a UTC timestamps, but all operations on the value are performed using the current session time zone defined by time zone parameter. Time zone underscore NTZ or date time stores the timestamp value without taking a time zone into consideration. Sometimes that is also referred to as a wall clock time. Timestamps underscore TZ stores the timestamps together with the time zone offset. When a time zone is not provided, the value of the current session time zone parameter is used. Due to limitations of the Gregorian calendar, Snowflake recommends that you avoid using years prior to 1582 in timestamp values. The time data type is used for storing time values formatted as HHMISS. Fractional seconds are also supported by adding an optional precision parameter, for example, time 9, which means nanoseconds, and it's also the default. All operations on time values are performed without taking any time zone into consideration. Okay, I'm not gonna write about the 1582. Probably not gonna do that. The following Snowflake data types. I will drink coffee. The following Snowflake data types can be used to store semi-structured data. Variant can contain any data type including object and array. The maximum length of a variant value is 16 megabytes. Array contains 0 or more elements. Just like arrays used in programming languages, each element is addressed by its position in the array. Object can contain key value pairs where keys are stored as varchar data types and values are stored as variant. A combination of variant, array, and object data types enable you to represent data in semi-structured formats such as JSON, Avro, or Parquet, and XML. Ooh, I hope we're gonna learn more about Parquet. Chapter 8 discusses working with semi-structured data types in more detail. Take me for my element. Nah. Just like arrays used in programming languages, each element is addressed by its position in the array. Snowflake, Snowflake provides geospatial data types, including points, lines, and polygons on the Earth's surface. The following geospatial data types are available. Geography uses the VGS 8484 standard, where points on the Earth are represented as degrees of longitude from minus 180 degrees to plus 180 degrees, and latitude from minus 90 to plus 90 altitude. And latitude from plus 90 to 8. Plus 90 to, oh my god, okay, one more time. Minus 180 degrees to plus 180 degrees, and latitude from minus 90 to plus 90. Altitude is currently not supported. Geometry. Coordinates are represented as pairs of real numbers with units that are determined by the Spatial Reference System, SRS. If you want to store geospatial data in Snowflake using various input formats such as longitude and latitude, WKT, WKB, GeoJSON, and similar, Snowflake recommends that you convert this data into geography and geometry data types. This will improve query performance by taking advantage of geospatial functionality as compared to querying data in its original format. In addition to system-defined functions provided by Snowflake that you can use in SQL queries, you can also write your own user-defined functions and use them similarly as the system-defined functions. A key difference between system-defined functions and UDFs are that UDFs are database objects, which means that they reside in the database and schema. When you call a UDF without fully qualifying the name, Snowflake will look for the UDF in the database and schema that is in the current session. A system-defined function is never fully qualified and can be called from the database, from any database or schema. A UDF can be written in one of these supported languages: SQL, JavaScript, Java, Python. Many factors can affect which programming language you choose to write a UDF, including the capabilities of the language, whether you already have code in a particular language. For example, if you have a .jar file that contains a method that does the work that you need, you might prefer Java as your programming language. Whether a language that has libraries that can help you to processing the tools you need. For example, if you use Python machine learning libraries, you might prefer Python as your programming language. Whether you are migrating SQL stored procedures from other database systems. Although the syntax may differ, you might prefer SQL as your programming language to minimize the amount of code rewriting. A UDF can return a scalar or tabular results. Do we remember? Because we actually went through this. So scalar means maybe one row, and tabular means that it's going to return a whole table. A scalar function returns a single column or a value. When you use a scalar function in a query, it results in one output row for each input row. Tabular UDF. A tabular function, also called a UDTF, user-defined table function, returns 0, 1, or many rows for each input row. In a tabular UDF, the return statement contains the table keyword. You must also specify the names and data types of the columns that the function will return. UDF names may be overloaded, meaning that you can have more than one UDF with the same name, but with different arguments, either by the number of arguments or the argument data types. When calling an overloaded UDF, the correct function is determined by the arguments that were provided in the function call. Let's work with some examples. Similarly to creating tables and views, functions must be created in the database and schema. The following examples continue to use the sales database and the sales data schema. A UDF can, okay, so now we're gonna go into, I think we talked about it. We're gonna read the whole chapter and then we're gonna write some stuff. I think this is how it is, because maybe if we wanna write something, it's gonna be at the end if we have any questions. So I don't know how long but this is extremely strong. Okay, whatever. A UDF can either use a general expression or a query expression. An example of a UDF with a general expression is a function that calculates the cube of an integer. Here is a code that creates this function using SQL. Create function, And also I'm thinking, right, that, you know, it would maybe nice to have like the ebook and copy paste these codes. But I think as long as it's not long, because these are like short queries, I think it's super nice that you write them down, because it's like, okay. Qualified. Yeah, this we know. This we know. I mean, it's very obvious. Not IDF. Isten ments. meaning that you can have more than one UDF with the same name, but with different arguments, either by the number of arguments or the argument data types. When calling an UDF, overloaded UDF, the correct function is determined by the arguments that were provided in the function call. We're gonna do this underlying doom, meaning this means that overloading is not combining multiple UDFs for some collaborative calculate function. What is the word? Like processing, that you can use the same UDF name but for different type, but for different functions, as long you specify the correct argument in the function call. Only 30 minutes left. I would definitely not take a 5-minute break now because I only have 30 minutes left, so I would do it for another 20 minutes and then of course have the 10 minutes of like so in my opinion. Nice. Let's work with some examples. Similarly to creating tables and views, function must be created in this database and schema. A UDF can either use general expression or query exception. I need you to stop capitalizing my shit. Don't ever do it. I can do it myself. Please stop doing this. As you can see from the code, the name of the function is cubed. The function takes x as an input argument with data type integer. The return data type is also integer. In the body of the UDF, between the dollar signs, you have a single expression that multiplies the input argument by itself 3 times, thus calculating the cube of the argument. No return expression is needed because the function knows that the result of the expression in the body is what will be returned. You can execute the function by calling it in a query. So let's go to Snowflake, not Taper Monkey. And we are in sales and sales data still. So what's the problem? Create function cubed returns the integer. As you can see from the code, the name of blah 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 blah. You can execute the function by okay. I'm sorry. Huh? Yeah. The result is 27 as accepted. I don't that's the thing, right? Like, because no idea what you mean. As you can see from the code, the name of the function is cubed. Okay, so let's go back. And if I, can you, like, I really liked in, when I was doing the Python, that if I would copy from VS Code, it would copy the colors. But in this case, no, it will not, unfortunately. So anyway, let's break this down, because I know it's supposed to be easy, but remember, I'm not a smart person. As you can see from the code, the name of the function is cubed. The function takes x as an input argument with data type integer. Yes, I'm gonna even write it here. The return data type is also integer. In the body of the UDF, between the dollar signs, you have a single expression that multiplies the input argument by itself 3 times. I don't understand. I don't understand. Create cube of. Okay, so because I think I don't understand this. Because I think calculates. I think that's my problem. Calculate a cube of an integer. What the fuck that means? So calculates the cube of an integer. What do I share now? I don't share my. The cube to cube a number, but what is a cube? So we're gonna of course share the screen. In arithmetic and algebra, the cube of a number is its third power. That is the result of multiplying 3 instances of n together. The cube of a number, n, is denoted. Okay, Maybe if I just change this to Hungarian, I will maybe understand. Where is Magar? Magar. Unfortunately, this is rocket science. Of the volume of a geometric cube is the cube of its sideline giving rise to the name. The inverse operation that consists of finding a number whose cube is n is called extracting the cube root. It determines the side of the cube of the given. No idea. No idea. Okay, sorry. You can add this if you want. Another type of UDF is one that returns the results of an SQL query where the query expression returns at most one row. As an example, you might create a UDF that counts the number of customers in a given market segment in the Snowflake sample database using the following SQL code. Okay, let's do it. This is cool. This is cool because we're gonna like properly explain. Will it work? As you can see from the code, the name of the function, okay, so we will properly note this down. At most one row. English, motherfucker, do you speak it? Another type of a UDF is one that returns the results of a SQL query where the query expression returns at most one row. What do you mean at most one row? Okay, I'm not mad, by the way. I'm okay. Return at most one row means when the SQL query inside the UDF is executed, it can produce 0 rows or 1 row, but never more than 1. So you can just scale, so this means that this is a scalar function. Yes, exactly. So why don't you just say it? Why don't you just say another example of a UDF is one that returns the result of an SQL query where the query expression returns at most. You are really, I think it's not written well. I'm sorry. Another example of a UDF is one that returns the result of an SQL query where the query expression is maximum 1 row. Returns where the query expression returns maximum 1 row. Meaning it's the scalar UDF. Okay, I'm just bitching. As an example, you might create that counts the number. The example will count the number of customers in a given market segment in the Snowflake sample database using the following SQL code. We are running out of time. As you can see from the code, the name of the function customers by market segment. The function takes segment as an input argument with data type varchar. The return data type is integer. Because you will be a whole number as the count. In the body of the UDF, there is a single SQL query that returns exactly 1 row and 1 column, which is the value that the UDF will return. Select count from where customers equals segments. The query in the UDF can refer to the input arguments of the function, as in the previous example where you provided the market segment name as an input argument. Yeah, whatever. Note that there is no semicolon in the body of the UDF. You can execute you can execute the function. Sect. The result is the number that represents the numbers of customers in that market segment. You can test whether the UDF is returning the correct result by executing the SQL query used in the body of the function manually. The query expression in a UDF can reference database objects such as tables, views, and sequences. If an object in the expression is unqualified, it will be resolved in the schema that contains the UDF. In case of the expression references an object in different schema, the owner of the function must have said, yeah, exactly. Similarly, as in views, the user calling the UDF does not need access to the objects referenced in the query expression within the UDF, but only needs the privileges to execute UDF. Meaning, the reason why, this is also against security, because you don't want people to, get into the database or look at data, but you want them to make calculations or want to do them some work. So then you can do this. I have to go to work very soon. Perfect. You can test the result if it's correct by running the query on the actual table. Yes, we will do this tomorrow. All right, so this is how much we progressed. I really like this. I'm feeling the spirit coming back because it's slow, but I think it's super nice that we take each chapter one by one, get internalized. This is how you at least have some sense of what you're dealing with. So very nice. Tomorrow Saturday, and I'm gonna do it. I'm gonna do it again in the mornings. So something like that. Peace.